Physics 100, Conceptual Physics, Chapter 4, Homework, starting with Q6. Q6 says, two equal forces act on two different objects. We have object 1 and we have object 2. And we have the same amount of force acting on them. Object 2 has a mass that's 10 times the mass of object 1. So this is m, this would be 10m, 10 times as much mass. Will the more massive object have a larger acceleration, equal acceleration, or less massive, smaller acceleration than the less massive object? All right, so if acceleration equals F net divided by m, the larger the mass, the smaller the acceleration. So the more massive object is going to have 1/10 the acceleration because it's 10 times as big, 10 times as massive. So once more massive object has a smaller acceleration. That's what it's asking. Q7. A 3 kilogram block is observed to accelerate at a rate twice that of a 6 kilogram block. So again, we have two blocks. We have 3 kilogram and we have 6 kilogram. And this one has an acceleration that is twice as big, so 2 times the acceleration. So if the acceleration of this bigger block is a, then the acceleration of the smaller block would be 2a. And the question is the net force acting on the 3 kilogram block therefore twice as large because it's got twice the acceleration? Well, we're going to use the same equation. F net equals ma. Well, F net equals m times a, and the m for the top one is 3 kilograms, and the a we said is 2 times a. So we have a total force of 3 times 2, 3 times 2, which is 6 times a, newtons. For the big block, we have F equals m times a, which is going to equal 6 kilograms, times the acceleration just a. So that gives us 6a, newtons. They're going to have the same force. So the answer is no, they have the same amount of force. Question 8 says we have two equal magnitude horizontal forces acting on a box as shown in the diagram, which I sketched right there. Is the object accelerated? Well, the answer is no. It is not accelerated because the net force is the positive force minus the negative force. They're the same, so there's the same amount of push or pull. So the F net is equal to 0, and therefore if F net is 0, and F net equals m times a has to equal 0 as well. Q2 says, is it possible that that object is moving, given that it's got equal forces on both sides? All we know is that the acceleration is 0. From the first law, we know objects in motion can stay in motion unless acted upon by an outside force, an unbalanced net force. Well, there is no net force on it, but it could be moving. It could already be moving. It's just not accelerating. So the answer to this one is yes. Just not accelerating. On to the exercises. Exercise 1. A single force of 40 newtons. So that makes the net force easy. F net is since there's only one force acting on it, the total force is 40 newtons. So F net is 40 newtons. That's a 4 and a 0, 40 newtons. And the mass of the object that it's acting on is a 5 kilogram block. So the mass is 5 kilograms. What is the acceleration? Acceleration is F net divided by m. So we got 40 divided by 5, which is 80 meters per second squared. E4 A 3 kilogram block is being pulled across the table by a horizontal force of 80 newtons. There's also a frictional force of 5 newtons. All right, so we have our block. We know its mass is 3 kilograms. We know there's an 80 newton force pulling on it. There's also 5 newtons of frictional force holding it back. Frictional force always opposes the motion of the object. So we're asked to find the acceleration. To find the acceleration, we need F net divided by the mass. We know the mass. The net force is the sum of the total forces. So we have 80 newtons in the positive direction. We have 5 newtons in the negative direction. So 80 plus negative 5 is 75 newtons of force net divided by 3 kilograms gives us 25 meters per second squared. Don't forget to box up your answers so that they're easy to find. E7. Let's see, I gotta turn the page. Exercise 7, we have 2 forces acting on another box. We gotta draw the picture. So we got big force of 50 newtons going to the right, and we have 30 newtons going to the left. I'm going to call the left the negative direction, and we know the acceleration that's given to us. Acceleration is 4 meters per second squared. The question is, what is the mass of the box? For that to be true, what is the mass of the box? F net equals ma. So m is going to equal F net divided by a. The net force is the sum of the forces. We have 50 plus negative 30, which gives us 20 newtons of net force, divided by the acceleration, which is 4 meters per second squared, leaving us with a mass of 5 kilograms. All right. Next, exercise number 10. What is the weight of a 40 kilogram mass? Remember that weight and mass are related quantities, but not the same. Weight is the force of gravity. That is what weight is. That equals the mass times the gravitational acceleration. The mass of the object is 40 kilograms times gravitational acceleration, which is 9.8 meters per second squared. 40 times 9.8 gives us a weight of 392 newtons. Exercise 18 is probably the trickiest one on this homework set, to be honest. We have an upward force acting on an object. So we got an object, and we're given the mass, 2.5 kilograms. And we know that there's an upward force acting on it of 27.5 newtons. Part A says, what is the net force acting on the ball? So it might seem at a glance to be kind of obvious. That's supposed to be a question mark. It might seem obvious that obviously 27.5 newtons is acting on it. But you can't forget that there's also a gravitational force pulling it down. So to figure out the gravitational force, Fg, also known as the weight of the object, we take the mass, 2.5 kilograms, and multiply it by 9.8 meters per second squared. That's going to give us the downward gravitational force of 24.5 newtons. So the net force is going to equal the upward. Since it's down, by the way, gravity is going to be downward. We got to make sure we keep consistent. So we have our 27.5 newtons up minus or plus negative 24.5 newtons in the downward direction, giving us a net force of 3 newtons. It's tricky because people forget to do the downward gravitational force. And if you do, the rest of it's wrong. Next, it asks for the acceleration of the object. Acceleration is F net divided by m. So we have our 3 newtons divided by our mass of 2.5 kilograms, and we get an acceleration of 1.2 meters per second squared. All right, last but not least, SP1. Since this is problem 1, we have another box on a table. It says a constant horizontal force of 30 newtons is exerted by a string attached to a 5 kilogram block. So 5 kilograms, 30 newtons. And the block also experiences a 5 Newton frictional force. So that's in the negative direction. So we got negative 5 newtons going that way. Part A says, what is the horizontal acceleration? If we're finding the acceleration, it's going to be F net divided by m. The net force is going to be the sum of the forces, which is 30 newtons plus negative 5 newtons, and divided by the mass of 5 kilograms. 30 plus negative 5 is 25. 25 divided by 5 gives us an acceleration of 5 meters per second squared. All right, part B, it says if the block starts from rest, V initial equals 0. How fast is it going after, or it says what will its velocity be after 3 seconds? So time is 3 seconds. I want to know the final velocity. V final equals V initial plus A times T. That's 0. A we found in the first part is 5 meters per second squared. Time is 3 seconds. And we end up with V final equals 15 meters per second. So after 3 seconds, it will have accelerated to 15 meters per second. Part C says, how far did it go? How far will it travel during that time, during those 3 seconds? So delta x equals V initial t plus 1/2 a t squared. V initial is 0. So we end up with 1/2 times a, which is 5 meters per second squared, times 3 seconds, quantity squared. 1/2 times 5 times 9 gives us 22.5 meters. And that's it. That's the end of this homework set. Let me know if you have any questions.